Can you all see the whiteboard? Hello? Yeah. Can you all see the whiteboard? It's blank.
Yes, we can.
Yeah. So any questions, or we should have sort of go ahead? I suppose it was a fairly straightforward class last time. I mean, I was trying to I made a generalized model for inhibition kinetics and picked up 3 specific cases: competitive, uncompetitive, and non-competitive, which is actually non-competitive is a very strange term because it actually represents a combination of competitive and uncompetitive in exactly equal proportion. So there are examples of this. I have put this book on Soro, as well as there are 2 books there, and inhibition kinetics is something that you can read, and also we have covered it in the lab. So I hope you are able to practice these problems and choose values. But let us sort of do a little bit of algebra so that, and this will be in general, but I would expect you to sort of go back and put numbers and test it out. So let us start with, and the purpose of the algebra is not to just do the algebra, but the purpose of the algebra is to also elucidate concepts that are not obvious. I mean, theoretically it is obvious, but if we do a little bit of algebra, we should be more comfortable with stuff. So really, let me not write the generalized equation. I don't want to waste time, but you all remember your basic equations. I wrote for competitive inhibition. For competitive inhibition, I wrote the following expression, which was putting B and all those things equal to 0. I wrote it as VMS upon what was it? Km. The Km apparent was changing, right? The Km becomes Km apparent. Km 1 plus I by Ki. So Km changes and S remains the same. That all of you remember this? Really? Okay. So really, actually, it was if I remember correctly, it was a very similar expression. It was actually Vm S upon. I mean, it's actually Km, but I can write it as Ks. The Ks is the more general expression. Km is used only when you are talking of Michaelis-Menten kinetics, and you have this 1 plus S by Ks plus I by Ki. You remember this expression, which is exactly derivable from the fact that these are the unbound. I mean, this is the total enzyme concentration, E plus Es plus Ei, and this represents this. I hope you remember this, that this represents E, this represents the E fraction, this represents the Es fraction, and this represents the Ei fraction. And so this is the total, and this of course represents the Es fraction. So this part really is the fractional saturation into Vmax is the velocity. So I hope you remember these derivations, right? And so in a very interesting way, suppose, and this happens very commonly, suppose that P was the inhibitor. The product itself was the inhibitor, which really means that we are not writing in a function like this, E plus S is equal to ES. अरे बिल्कुल beginning में शुरू हो गया. Oh God. Can you hear me still? Hello? Can you hear me?
Yes, sir.
Yeah. So instead of this E plus I, this is going to plus I kind of stuff, we forget this part and we say ES goes to EP and then goes to E plus P. This is the kind of formulation I can make, because now the product, this is not, so notice that this formulation is the reversible formulation, but I can also make this as the product as an inhibitor, because I could write this as E plus P here also. You understand? And so the formulation of fractional saturation will remain the same, and exactly along these lines I will be able to write V is equal to Vmax S upon Ks divided by 1 plus S by Ks plus P by Kp. Do you follow this argument? Or should I sort of explain this further? I mean, we can find out the fractional saturation, but notice that again, the ET here is nothing but E plus ES plus EP. And EP can simply be found out as E into, sorry, Kp will be equal to E into P upon EP, the dissociation constant for product. So exactly the same formulation will be arrived at this point as well. In which case you can actually then calculate what is the inhibition constant, the rate of reaction and how it goes. So the numerator now contains a P term exactly in the same way as the I term is contained. So now here again, notice that this is K apparent, which is changing, which is Km apparent, because this is then this whole thing can be replaced as Km apparent plus S. So I made this drawing where I was a constant. VMS Km apparent plus S, right? And Km apparent was increasing as I was increasing, and therefore my graphs were going like this. First, they without inhibitor they were going like this, and as I increased the inhibitor concentration, they went lower and lower and lower. They were going lower and lower like this. Are you with me till now? Right? And so this was increasing I. Now notice the problem is much more complicated, because not only is Km apparent changing, but it is changing as the reaction proceeds, because more and more product is formed. So it is not a simple formulation. Therefore, this formulation makes more sense. Writing it like this: VMS upon Ks, 1 plus S by Ks plus P by Kp, because P is now increasing as S is declining. So while S goes down in this direction and therefore velocities go down, the Km also increases, so velocities go down faster and faster. So obviously, I mean, geometrically it is irritating to interpret. It is far more easier to solve this integral and write P as S naught minus S. And so if, as I made a bad mistake in my exam, if Ks and Kp are equal, then the numerator simply becomes 1 plus S naught, because this is S naught minus S, S naught by Ks or Kp, which is a constant. You get the point? So really we have various kinds of formulations that are possible. More importantly, we could also make this more complicated by adding the no, sorry, this one. Sorry, no, not clear that.
Sir?
Yeah.
Sir, I just wanted to, sir, several people have asked me to request you to extend the submission of the lab report submission. Because sir, we have been asked to onboard, so everyone is
Okay.
this Sunday.
Okay.
Because of the mid-semester break, there won't be a class on a Monday, so there won't be a report to submit for the next week.
भाई आप लोग थोड़ा जल्दी करिए. I mean, if I want to add one very important point, that you people have to submit one term paper.
Yes sir, about that as well.
और उसका डेट कब दें आपको? ये मतलब एंड सेमेस्टर से पहले नहीं हो सकता है. So I will agree to extend the lab report on the ground that you will submit the term paper within, let us say, the next 2 weeks. Can you submit it by 15th March?
Sir, like what can, yes sir, we can do that, but sir, what can be the like latest that we can do?
Well, 20th March, that is about it.
So sir, then can we just have it for 20th March, sir? Because what happens is that during the last month, we get assignments for almost all courses.
That is why I wanted to submit it early. You people have this very nice habit of saying that I will, you know, I have a very simple philosophy in life. Whatever problems are there, I will postpone them.
Yes.
That's a fantastic philosophy. I remember in my BTech days, I used to do the same. And I used to get very angry with faculty who used to shout at me, but I have now reversed. I am now on the other side of the table. So I shout at the same BTech students who do what I used to do. So please stop and submit it early. You know, there is no point getting irritated about something you have not done rather than sitting down and doing it. That is less irritation. Just get a bit more disciplined. And I think this whole this break that you have had, and the fact that you don't talk face to face with faculty, so the faculty is also some nameless person who's creating trouble. You people are not relaxing. I mean, you're relaxing too much and not relaxing simultaneously. So you need to just sit down and do this. And I gave a very I thought I gave a very clear option. Term paper can be any topic in enzyme science and technology, and you have studied any topic, which means really you can pick up inhibition or enzyme action or kinetics or substrate or that lecture that you were supposed to see, and enzyme science and how enzymes function. Or I mean, I give you the option of sitting down and one day sitting down and reading stuff. I mean, this ability to slightly enjoy new academic knowledge and information for its own sake is an ability that you have to learn at some point in your life. Otherwise, everything is a burden. It is an exploratory aspect where enzyme science, I have covered nothing. I have covered 5% of the course. And there was no way I could have done more. I can't race through and try to sort of emphasize to you that I know a great amount of things in enzyme science. That's not the idea.
Yes, sir, we can submit by 15th because we'll all be on board by 13th March.
Yeah, you'll be bored. Just sit, and you have Google now. In our days, we had to go to the library and read papers. Pick up interesting topics on kinetics, on thermodynamics, on enzyme inhibition, on enzyme production, enzyme action mechanisms, and submit. I don't want a huge topic. I just want a 4-page write-up in your own words. Read 2-3 papers, see a criticism of the paper, write your own conclusions about those papers in one topic. See, this is what I feel is what is happening in enzymes. Papers on modifying enzymes to make them more thermostable, papers on anything, structural biology, protein structure, term paper to do with enzymes. I mean, I can't make it easier and more general. But write it in your own words. Write read 4 papers and write 4 pages. That is it. And I want to see how creative you are. The idea is not to sort of, as I said, even in this, I mean, the idea is not to check your ability to do algebra and integration. I apologize twice. I will apologize one last time. I'm extremely sorry that I did not put this Ks and Kp equal in the midterm. The idea is not to make you do a integration by parts, which it became because of the fact that Ks and Kp were not equal. But otherwise, it would have become a simply an exponential function declining to p, and then it's a simple integration to go from here to here and find out the time. But anyway, so idea, please. So when do you want to submit the lab report? Next, I have to change it on Moodle, or you submit it. Tell me the date. Tell me the date.
Sir, 6th March.
Okay, 6th March.
Yes, sir. And then we can submit the term paper on 15th.
Term paper on 15th March. Yeah. Try to finish this up, wrap this up, please.
Yes, sir.
Okay. Okay. Thank you. So these are the 2 things that we have covered. Now, can we go back to the subject?
One question regarding the term paper. Should we type it or does it have to be written?
I think better type it. It is easier to read.
Yes.
4 pages of typing is not very difficult, right? I hope.
Yes,
3, 4. I mean, when I say 4 pages, I say 3 to 4 pages, right? 4
yes,
pages.
Typing is easier.
Type it, please. Yeah. I mean, it's comfortable to read. Okay. And it is not a small topic. It contains 20 marks. So it's as much as 2 quizzes or 1. And it is 20 marks because I really want to see when you have typed 4 pages, have you given it thought or have you done it mechanically? So it's important. When I say it is open-ended problems are not necessarily non-serious. When I say any topic, I also mean that you study the topic seriously. Write it in your own words. You can review a particular area or a particular development and its critiques, whatever you have understood till now. Okay? When I say any topic, it does not mean it is casual. It means whatever topic you do, study in depth, do some exploration. sit and explore one subject and you will realize how many interesting subjects are there. This is to inculcate into you a habit of reading and doing research, because biotech as a subject can never be covered in the classroom. It is too vast and it is growing too fast and it is growing in too many areas. Okay, so there's no way any faculty can do justice to any course. So it is upon you to at least have a flavor of what is going on in the world. So it is serious. And there was a time, long time ago, when IITs were started, we were told that minimum contact hours so that the students can sort of explore and read. But now it has, because of unfortunate situation, that we are now sort of insisting that you have to attend classes and see to it that you give exams. The idea is to self-motivate you. Anyway, so think about this. That is the only my small effort in this direction, to make you think and read. I mean, I can take a horse to the water, I cannot make it drink, but you will discover in when you're older that this ability to sort of read in depth about a subject, enjoy it and write about it, think about it, will come in very, very useful. So anyway, yeah, let us go back. So really the idea is that okay, we can make this more complicated. For example, this is the basic expression for I by Ki, but what happens when we have inhibition as well as, for example, and reversibility, which is also very common, especially in metabolics engineering. So we have inhibition as well as reversibility. So this is a basic expression for inhibition. Okay, but now we have a reversible reaction. So and this is where I wanted to go back and derive it on your own, because as I said, we can do the algebra, but remember your kinetics, Vms by Ks. This is the basic expression here. So now you can well imagine, and I'm doing this right now for you. So instead of doing this, I write Vm by Ks, and you realize this, right? S minus P by K equilibrium. Because it has to go to 0 at S equal to when S and P are in equilibrium. So this numerator, instead of S, becomes now S minus P, that 1 minus rho expression part here, right? I can take out S, 1 minus rho. Okay, this is the same thing as Vm, the same Vm S upon Ks into 1 minus rho, right? So this is one, and in the bottom, we simply have 1 plus S by Ks plus, of course, I by Ki plus P by Kp. That is it, job done. This is the reversible form of the competitive inhibition kinetics, where I is an inhibitor and P is, so they are both acting in very similar ways, as I told you, I by Ki, P by Kp. You remember that's what I did, I by Ki, and when P itself was I, then I simply replaced I by P and not P by 1 plus S by Ks plus P by Kp. So here you can see both terms have come about. 1 S plus Ks, I by Ki, P plus Kp. Again, same logic. This is Et. This is Et. E, Es, Ei, Ep. Can you follow this? Are you following what I'm trying to say? The denominator is nothing but Et. The E, the Es, and I'm not doing the algebra, I'm sort of jumping it. And this, instead of S, it is this S into 1 minus 1. So this represents the reversible form of the competitive inhibition. And I would like you to sit down and derive the reversible form of the generalized equation, or at least the reversible form of the non-competitive inhibition or the uncompetitive inhibition. How would it look like? And these are the questions that I leave for you to do. Is this all right? Can you do this? Can you do this algebra? For the this is the competitive part. Can you do it for uncompetitive, or even the generalized equations? I think the book by Soro has Herbert Soro has these expressions available for you, so you can check whether you have been able to derive it correctly. Okay, so this is what I am sort of jumping a little bit, but I hope the algebra is obvious. So I'm not going to do the algebra again and again. I think that you people want me to go a little bit fast, so I will leave this expression for you to derive, and I hope you understand the logic of how we derive this. Now, let us go on, and now let us come down to the same way that we were doing things. Let us now come down to the elasticities of the reactions. Remember your elasticity functions? E V by S, and of course EV by I. But we'll come to EV by I later. Let us do EV by S. And as I showed you, that in monod kinetics, that this was the way it was, right? The elasticity here, E was 1, and here E was what I'm saying, E was 0, E was 1, and somewhere here it was between 0 and 1. Between 0 and 1. 0 to 1. It goes from 0 to 1 as it. So really, it is actually, elasticity is actually, as I pointed out, 1 minus 1 by V by Vm. Remember this expression? And this holds for this as well. Okay. Hello? Can all of you hearing me?
Yes, sir.
Yeah. So tell me in 1 minute flat. Here is an expression for the competitor inhibition. So what is elasticity? 1 minus V by Vm. ये तो आप कर सकते हैं. So I'll give you some 2 minutes. If you do it on your own, it will be better. 1 minus V by Vm, what is that equal to? This is simple maths. This is V, and so this by Vm, and 1 minus that.
So we'll get 1 plus I by Ki divided by 1 plus S by Ks plus I by Ki.
The whole denominator. All of you get this? Very obvious. And what I will do is to save some ink on my, not ink, save the clutter in this. So we write I by Ki as the inhibitor concentration makes no sense other than we write this as I, small I. Makes more sense, right? It's the I by Ki factor which is always important. Similarly, it is S as a function of Ks which is more important. We can write this as alpha. These are by definition. Hai na? So 3 lines. So we define small I as the inhibitor concentration as a fold times Ki. Is it 5-fold, 3-fold, 2-fold equal to? So I equal to 1 means I is equal to Ki. And similarly, we write substrate concentrations in terms of how many times it is of Ks. We can write this as alpha, in which case we can write this as 1 plus I upon, it just looks neater, 1 plus alpha plus I, right? Okay, and of course, you remember the second expression that I had derived long time ago, and that's also valid, EV by S for when there is no reversible reaction. For simple kinetics, EV by I is equal to 1, right? And therefore, EV by I becomes equal to, go ahead. Hello, please. Okay. Hello. Are all of you with me till now? So you can also
Yes,
do ln and the equations that I had done for elasticity and derive this. You can do this. I mean, I leave it for you as a small practice. Again, you can actually do this. Do the formula. You know, remember elasticity of this expression divided by this expression will be just elasticity of this minus elasticity of this, and then you know all these expressions. So you can do this. It is not a very difficult part. So you can use the elasticity rules. No. You can use the rules of elasticity that we had derived.
Hello.
Sir has left the meeting.
No, I have joined again. I've not left it. I got logged out. Can you
Oh,
hear me now?
yes, sir, we
Yes, sir.
can.
Yes.
Can you see the screen? No.
Not yet, sir.
You can see the screen?
No, sir.
No. Can you see it now?
Yes. Yes, sir, we can.
Can you see the board now?
Yes, sir.
Yeah, thank you. So don't leave suddenly saying that I have left. Just wait for 2 minutes. I have all these computer problems which I can't resolve. So I hope you will bear with me. Right. So can you? So do you so we have these two expressions for which we can derive by rules of elasticity. I jumped the gun and said I will use this basic equation of EV by S being equal to 1 minus V by V max. But you can also use this expression itself and apply the rules of elasticity and get to the same expression here.
So
So please
EVI
go
should
back.
be alpha divided by 1 plus alpha plus I, right?
No, minus I. Yeah,
Sir, it would be
this.
alpha.
So
Oh,
the
achha,
sum
sorry.
of both has to be 1.
I know. I think this is this formula. This formula is correct, but I think EV by I plus EV by S equal to 1 is no longer valid. I don't think this is valid. Can you let us shall we do this algebra or shall I leave it for some time? We will come back to this. So take it from me that this is right. I will come back to this later. This is okay. This part is fine. I will actually derive this expression by actually doing this. I will write EV by I mean EV by I of Vm S upon Ks, right, minus E of 1 plus S by Ks plus I by Ki. And we are doing it with respect to I, remember, not with respect to S for this part. Okay, and notice that for I, what is this expression? This is a constant. Okay, so it is 0. Hello? Are all of you with me?
Yes, sir.
Yeah, so it's 0. And then let us apply the rules. For 1, when it's addition, what do you get? E of 1 into 1 divided by 1 plus S by Ks plus Ki by I by Ki, right? So let us keep this value. And then plus E of S by Ks, again a constant, upon into S by Ks upon 1 plus S by Ks plus I by Ki. Am I rushing through? But I hope you can do this. Plus E of I by Ki into I by Ki divided by the numerator 1 plus S by Ks plus I by K. I hope I have not made a mess here. So can you now tell me what is this expression equal to?
Yes, it would come out as what you'd written previously itself.
What I wrote. So I think this formula is a mistake. This formula is a mistake. So you will get EV by I as minus I upon 1 plus alpha plus I. Okay, got it? Because only this expression will count with a minus sign. Nothing else will count. So it will be alpha upon this stuff. Right? But this is 1 because this is first order. These are all zeros. This is first order. This will be 1 I by Ki upon 1 plus I by Ki. Are you getting this, all of you?
Yes, sir.
Simple enough, yeah. Okay, fine. And let us assume that all. So now the point really is not to do this algebra. The point really is to understand what is happening. So what are we looking at here? Let us look at just EV by S for the time being. And let me rub out everything. So let us we are looking at EV by S as, what did I write just now? I forgot. 1 plus I upon 1 plus I plus Ki, 1 plus I plus alpha. And now see, notice that really what is happening is that this is S here, this is V here, And as I said, this is the reaction rate, and this is the reaction rate when there is more inhibitor, right? So now the velocity has a sensitivity of 0 here and 1 here, and somewhere here is also 1. Somewhere here it is 0. At this point it is close to 0. But notice that at this point, now with inhibitor present, it is not 0. It is more close to 1. You get my point? At this point here it is 0. I want to do this geometrically, but at this point, when inhibitor is present, when I is there, it is no longer 0. It is sort of not 1, but maybe it is 0.5. Right? So really the plot of EV by S versus S has to decline by definition. Right? I mean, obviously, because as S increases, as substrate increases, the elasticity goes to 0. And at substrate equal to very close to 0, EV by S is 1. Right? But what happens when inhibitor is added? So if there was no inhibitor, I would have 1 upon 1 plus alpha. So this would be reducing to the standard, the inhibition kinetics for my monod kinetics, right? And as alpha, remember, is S upon Ks. So when S increases large, the denominator sort of increases hugely, right? And therefore this goes to 0, this part when S is large. When S is small and alpha is negligible compared to 1, this is at this point here where EV by S is equal to 1. So you can see that alpha determines, so alpha goes from 0 to infinity, this number goes from 1 to 0. Sorry, 1 to 0. When it goes to infinity, this goes to 0. So 1 to 0. So this will, so the elasticity tends from 1 to 0 as S increases. That's obvious. And so now you have this expression, and so you have I here in both numerator and denominator. This will go to 0 slowly. It will go to 0 slowly. So really this is the curve at a higher I. As I is increasing, my drop to 0 of E by S is not happening so early. It is not going to 0 now. See, it is not 0 here at this point when S is high. But it was 0 when there was no inhibitor. And so as I increases, the decline of EV by S as substrate concentration increases is not so fast. Is this argument clear? So this is the plot of EV by S versus S. Because of this plot. This is I increasing V versus S. This is increasing, so it reaches the V max, the asymptotic value, much slowly, and therefore EV by S declines to 0 more slowly. Make sense?
Yes, sir.
Hello? Yeah. So now what about EV by I versus S? Now let us have some information. Is this the correct line? ये ऐसे था तो ऐसे ड्रॉ कर दूं. बताइए. What happens to EV by I? Remember, now let us go to the algebra part. Minus, what is it? Minus I upon 1 plus I plus alpha. So obviously EV by I, when let us say as I is increasing, it obviously, remember that the elasticity is negative here. Okay? So it is actually minus 1 to 0. Obviously. I hope you realize this. So when I increase inhibitor concentration massively, what happens? And tell me, let us have some idea from you guys. Because it is not enough to do the algebra and to draw the graphs. It is important to do the algebra, draw the graphs, and then interpret them in a physical fashion. Is this the correct line? Or it's a poor drawing? Will it be like this or will it be like this? At least let us have an opinion on you guys, from you guys. Which is right? Is it the red line or is it the black line? I mean, come on, it's easy enough. Hold. For example, I am changing S. Remember, I am not changing I. So I am changing alpha. So
So I
take
guess
minus I as equal to 1. Just take I equal to 1. So what is this expression?
So I guess it's the red curve.
It is the red curve here, correct? So it's minus 1 upon 2 plus alpha. So as alpha increases, this declines. You understand? But in the negative fashion. So what happens when alpha is 0? What happens when alpha is 0?
the
And I
last
is equal to 1.
by 2.
भाई आप लोग थोड़ा सा सोचिए please.
So I guess the graph
Okay.
would be fourth quadrant, and as the alpha increases,
Yes, it is in the fourth quadrant. So
F-
let us sort of then, okay, let me sort of delete this and write it like this. Let us sort of have it properly now. Somebody should, I was hoping somebody would say something. This is increasing S, right? This is, let us say, EV by S, and this is the graph of EV by S, and declining sharply with I increasing. So this is increasing I. Is this okay? Now EV by I. Can you tell me how the graph looks like?
so it would start in the fourth quadrant with a negative value,
Yeah.
and then as F increases, it would approach up.
Sorry, 1 second. I think I just need to cut this. So this will start at the fourth quadrant. Will it go like this? Or will it go like this? What is this person? One, just hold on. Hello? Hello? क्या है? Sorry for this. Can you hear me now?
Yes, sir.
Hello? Yeah. So we have EV by I equal to minus I 1 plus alpha. Fix the value of I as a safe value of my I is 1 because it's after all I by Ki. And tell me, how does the plot look like? So which is the plot? What is the value when alpha is equal to 0? When alpha is equal to 0, it is minus. Oh God, again. Can you hear me still?
Yes, sir.
Hello? Yeah, so it's minus 1 upon 2 plus alpha. So it is minus half. So the curve goes like this. So and what happens when I values are, say, let us say it is 5, then it is -5 upon 6 plus alpha. Can you see this? So it starts like this at a lower value, right? So this is increasing enzyme inhibitor concentration. Can you see this plot?
Yes, sir.
Yeah. And now I will sit with you. I will not go ahead. I will go ahead with this later. Let us now look at uncompetitive inhibition for the timing. Please remember this plot and we'll go to uncompetitive. Then we will compare what happens when an inhibitor is added to the system in a metabolic pathway. Okay, let us ask this question right away. What happens when an inhibitor is added to a metabolic pathway? And this is conceptual, not algebraic. So I have a to B to C to D expression going on. And so suddenly I say I want to slow down this reaction here. So what happens when I add an inhibitor here? And when I add an inhibitor here, this reaction slows down. B increases. But because there is a lot of inhibitor, notice that inhibitor is high, therefore the elasticity with respect to B has not fallen. ले लीजिए please someone Amazon का. So again hanging. Can you hear me? Hello?
Yes, sir. You're audible.
Yeah, I'm getting into this very serious problem with this laptop. And you can see the screen?
Yes, sir.
And
we
you guys
can.
can see the screen? Yeah, okay. So now let us ask this question that when you have a reaction going from A to B to C and you have an inhibitor being added to slow down this reaction B to C, what is going to happen? Obviously, if this reaction slows down, then B will tend to accumulate. B will increase. Now notice that the inhibitor is slowing down the reaction, B is increasing, but because I has increased, the elasticity with respect to B, which is a substrate, has actually also increased. So the increase in B will actually increase this reaction. So you have two opposite forces, and I will talk about this in a detail in a later class. You have two opposite forces working. So any addition of inhibitor increases B, hence increases the reaction also. So actually the effect of a competitive inhibitor is extremely poor on a reaction which is part of a metabolic network. And that is why competitive inhibition is not so common in metabolic control. And I will come and explain this in more detail. I just want you to sort of keep this in mind as an example. Now, let us sort of, without wasting too much time, and I move very slowly, let us talk of uncompetitive inhibition. What is uncompetitive inhibition? So V is equal to, can you tell me the expression for uncompetitive inhibition? V max S upon, remember both of them were changing because it was actually Kn plus S upon 1 plus I by Ki. Actually AKI. Remember? This was uncompetitive inhibition. All of you remember this expression?
Yes, sir.
Hello? Yeah. And let us apply that same formula which I did for EV by S, which is 1 minus V upon V max. So, and take S upon Ki. Now let us do this fast as alpha and I upon, sorry, S upon Ks. I upon Ki as I. So can you now tell me what is EV by S uncompetitive? What is EV by S uncompetitive? 6.
So we would get km plus s into I divided by a plus ki in the numerator and then the same denominator.
Right. So EV by S becomes equal to. I mean, as a matter of fact, you can write it as therefore. So you realize that in the case of competitive innovation, it was only Km which was changing. Now the Km and Vm are both changing. So really, EV by S. I mean, I'm just doing algebra in a different way. I can write it as the same way as I wrote Michaelis-Menten kinetics, but I will have to write it as Km star upon Km star plus S star, something like this, right? Rather than writing Km star upon Km plus S, because now effectively both of them are changed. And so I can write this as, I mean, if you want me to, I can write this as Km upon Km plus S into this expression 1 plus I plus IB. Does that make sense? Oh, sorry, this Km. Okay. So what I'm trying to say is that this is equal to, how many of you derive this? 1 upon 1 plus alpha plus I alpha. Do you get this? Or you can do this formula. Apply it here. ठीक है ना, मतलब VM कॉमन ले लीजिए आप, 1 minus V by VM. So you know this whole thing divided by VM, right? So we go get rid of this stuff here, and then 1 minus this. Is it all right?
So the numerator should be km plus s, s into capital I divided by a plus ki.
No, it's this, no? 1 minus. Or shall we do it the more tedious way? Think about it. I mean, if I'm doing S, this function is as a constant. So as far as I'm concerned, this I can hold on. So I can do EV by S as E of VMS, that's just 1, right? Minus E of Km into Km, this is again gone to zeros, upon Km plus S into 1 plus I upon AKI, something like that. And this is a minus here in a bracket. This plus E of S into 1 plus I by Ki. Notice that this is 0 multiplication. So this is E of S, 1 plus this, E of this, which is 0, divided by into S 1 plus I by Ki, divided by the whole thing, Km plus S into, sorry, 1 plus I by AKI. Either do it by this method or do it by this method. You should get the same answer. And so I'm wondering why you are not, I mean, I just derived it. I was just looking at it 5 minutes ago and this is what I got. Am I got it wrong?
So the expression of E of V with respect to
V by
S.
S.
Yes, sir. So where you have written on the towards the right that Km divided by Km plus S into bracket 1 plus I by AKI. Sir, I'm saying the denominator, so numerator should have a plus S I by K AKI factor as well, right?
Is it? So we had.
So if we go for 1 minus V by Vm, then we should get it as
Yeah, let us go. Let us go ahead slowly. Yeah, let us do it then. Now that we are having some kind of contradiction, let us do this. 1 minus V by Vm क्या आ रहा है आपका? What do you get here? 1 minus 1 by Vm.
so
that's
Km.
1 minus S, okay, upon Km plus S 1 plus I by Ki, AKI, right? Is this all right? And so this
Yes, sir.
becomes.
In the numerator, sir, S, you've written 1, I guess by mistake.
Sorry. S. This is the expression 1 minus S upon, right?
Yes, sir.
Upon this, right? Now we take this and so we write as, oh, you're right, actually. So we write Ks plus S1 plus I by Ki. You are actually I by Ki, and then we get this as Ks plus S into I by AKI, right? Fine. And then
Yes, sir.
we open, yeah, and then we open this out and we divide this expression. So what do we get? This is I, this is I, small I, and this is 1 plus I. So it is actually, and then we divide by Ks as well. So we get, okay, I'm getting confused now. So I think either I have made some mistake or something, but this is what I derived in the earlier expression form. I don't know. So this is 1 plus, sorry, let me do it slowly then. S Ks plus Si upon Ks. And so we divide by Ks plus Si, that becomes a problematic thing, because we are not having a simple expression in the, so this is actually S star. Because I am not getting a Km here. That's the problem, right? So can we write it in terms of this Ks plus Is upon Ks plus S plus S into I, right? That is what we are getting. Ks plus
Yes,
Si upon Ks plus S plus Si, right? And if we divide every expression by S, or if we divide every expression by Ks, makes more sense. If we divide every expression by Ks, then I get 1 plus I alpha, and I get 1 plus alpha plus, what did I divide it by? Ks, I by alpha, right? No, I alpha. What am I saying? I alpha. 1 plus I alpha upon 1 plus alpha plus I alpha. But actually, this, I don't know why I got just 1. So it's actually 1 plus I alpha upon 1 plus alpha plus I alpha. So now this expression here, I don't know. Anyway, yeah, maybe I'll check it out and let you know. But I said, suppose we are running out of time here. So what I want you to do is find this out and check whether I made a mistake or not. Check it by the standard method. This is your basic B, your B here. And what I want you to do is the same way, plot EV by S, obviously in the positive quadrant, and EV by I, which is in the negative quadrant, versus S. And obviously we need to know how EV by S changes. Does it go like this, or not for uncompetitive inhibition, and even if it has to go like this, if it goes like this, and for I does it go like this or not, or how does it go? I want you to check this and let me know, and find out EV by I as well. So in the next class, next class is now we have a break coming up, so we will sort this out, and I will check out the formulas. This is for EV by I as well. Sorry, this was a bit of a mess. Doesn't matter. Go ahead. Any questions? Because this term here, as you can see, if I choose I as a constant, let us say 1, then this term here is actually 1 plus alpha upon 1 plus 2 alpha, something like that. Right? I is equal to 1. So how does it change? It, as alpha goes to infinity, this is 2 alpha, so this will go to 0. But as alpha is equal to 0, then it is 1. So as far as I'm concerned, this always has to be like this. That makes sense. As substrate goes to infinity, you will have to. But really, how does it change with respect to enzyme concentration, inhibitor concentration? This is the question that I want to know. As I concentration changes, what happens? Let us stop here. I think somewhere I lost the argument a bit, but that's fine. I'll explain it in the next class. But for competitive inhibition, it should be clear.
Yes, sir.
Yes, sir.
Okay, thank you. Any questions?
None currently, sir.
Okay, thank you.
Thank you, sir.
So let us stop the meeting. Thank you. Thank you.
Thank you, sir.